Hello, everyone. Today, I will explain the latter part of Death of Death. Thousands of years ago, human life expectancy was around 20 to 25 years, and even during the ancient Roman era, the life expectancy was about 25 years. It wasn't until the early 20th century that life expectancy increased to 50 years, and by the beginning of the 21st century, it had extended to 75 years. At this rate, it won't be long before we reach 100 years of age. However, there are also significant voices opposing the technology that aims to halt aging. Let's take a look at the story of Aso Taro, who served as the Prime Minister of Japan for 1 year starting in 2008. When I attend alumni gatherings, I constantly encounter people in their late 60s who roam around hospitals. Why should I pay money for those who only eat and drink without making any effort? Aso Taro stated. He suggested that in order to ease the financial burden on the nation's healthcare system, elderly individuals should be allowed to hurry up and die. While Aso Taro eventually had to apologize for his expression that seemed to neglect the concerns of elderly voters, this viewpoint is not uncommon among some scholars and politicians. Indeed, as life expectancy increases, some argue that the period of declining health and suffering has also been prolonged, with the end-of-life process being extended. When considering conditions like strokes, dementia, and other age-related ailments, it is suggested that living longer in old age may lead to more prolonged suffering without necessarily enjoying a higher quality of life. Shall we take a look at the thoughts of Francis Fukuyama, a Japanese-American political scientist and professor at Stanford University? Life extension is a perfect case of positive externalities, where it is rational and desirable for individuals, but it can impose negative costs on society. When people reach the age of 85, about 50% of them will suffer from Alzheimer's disease. The reason for this disease's explosive increase is simple. Thanks to medical advancements, people now live long enough to be susceptible to this dreadful ailment. Indeed, those advocating for the possibility of reversing or delaying aging present strong counterarguments. They propose that by postponing or reversing aging, numerous age-related diseases such as cancer, cardiovascular diseases, and diabetes can be prevented, reducing the suffering caused by these illnesses. Additionally, a decrease in chronic medical service consumption due to long-term illnesses would occur, and the elderly would continue to be active and productive members of the workforce, maintaining vitality and enthusiasm. Healthy seniors are more likely to save and invest than those suffering from diseases, and improvements in health can lead to reduced absenteeism in schools and workplaces, leading to higher levels of education and increased income. The British scientist Aubrey de Grey, author of Ending Aging, describes the voices opposing anti-aging efforts as pro-aging trance, and he stated the following. There's a very simple reason why so many people strongly advocate aging. Until recently, it was entirely rational. Aging was virtually unavoidable since there was no consistent idea of how to defeat it. Faced with such a dreadful fate as aging, and when one feels powerless to do anything for oneself or others, it is psychologically natural to embrace an idea that brings peace. To maintain this state of mind, one must relinquish all rationality about the subject and engage in bewilderingly irrational conversational tactics to uphold the irrationality. It's a small price to pay for inner peace. The silver industry is expected to thrive in various sectors, including financial and tourism services. However, if research on aging reversal does not progress, there are analyses suggesting that the current 4 million Alzheimer's patients in the United States could increase to 16 million by the mid-21st century, requiring an annual expenditure of $1 trillion for treatment. Currently, billions of dollars are being spent on caregiving for age-related diseases like cardiovascular conditions, diabetes, cancer, and others. The concept of the longevity dividend was first introduced in the scientific journal Scientist in 2006. Currently, there is a growing opinion that suggests redirecting the funds used to tackle individual diseases towards addressing the fundamental mechanisms of aging. Among the annual $30 billion budget allocated to medical research monitored by the National Institutes of Health, NIH, in the United States, currently, less than 10% is allocated for aging-related research. However, there are proposals to increase this allocation to 20% over a period of 10 years. Suggestions include extending research time dedicated to anti-aging studies, encouraging global charitable donations to anti-aging organizations, incentivizing corporate investments in this field, and increasing public funding for aging reversal research. Finding the cause of aging doesn't seem to be as expensive as one might think. Adults are composed of about 60% water. Moreover, the water is not the expensive Evian or Perrier mineral water. It is just ordinary water consisting of 2 hydrogen atoms and 1 oxygen atom. Bones contain 22% water, muscles and the brain have 75%, the heart 79%, blood and kidneys 83%, and the liver is estimated to contain 86% water. The percentage of water in the body varies with age, with children having up to 75%, adults around 60%, and older individuals around 50%. An average adult weighing 60 kilograms has about 42 liters of water in their body. Oxygen, carbon, hydrogen, and nitrogen, the 4 essential elements abundant in the universe and on Earth, make up 99% of all atoms in our bodies. They also account for 96% of the average age and weight, which is 70 kilograms. If we understand how to recover substances at the atomic and molecular levels, it can be easily achieved at a low cost. Considering nanotechnology as a form of synthetic biology, the author emphasizes that there is a high likelihood of successfully recovering atoms within the next several decades. Indeed, one of the Plan B options for humans on the path to aging reversal is cryopreservation, specifically cryonics. Cryonics, which involves the freezing and preservation of human bodies, had its origins in 1962 when American physicist Robert Ettinger published the book, The Prospect of Immortality. This concept has since sparked interest and debate regarding the potential of preserving human bodies at low temperatures with the hope of future revival and restoration of health and life. The idea of potentially reversing the early stages of clinical death in a technologically advanced future served as the foundation for cryonics. Robert Ettinger and 4 other colleagues established the Cryonics Institute in Detroit, Michigan, in 1976. The first patient to undergo cryopreservation was Ettinger's mother, who was preserved in a state of suspended animation at a temperature of -196°C, the boiling point of nitrogen, in 1977. In California, in 1972, Fred and Linda Chamberlain founded the Alcor Life Extension Foundation. The first patient to undergo cryopreservation at Alcor was Fred Chamberlain's father, who received a procedure called neurocriopreservation, where only the head is preserved in a frozen state. Cryonics has around 200 cryopreserved patients and more than 1,000 members. Similarly, the Alcor Life Extension Foundation also has a comparable number of patients, with 3/4 of them undergoing neurocriopreservation. The cost of whole-body cryopreservation at Cryonics ranges from $28,000 to $35,000, excluding standby, stabilization, and transportation fees. On the other hand, Alcor charges $80,000 for neurocriopreservation and $200,000 for whole-body cryopreservation, which includes standby, stabilization, and transportation costs. In 2005, Cryo-Rus emerged in Moscow, and since then, there have been plans or small-scale organizations established in Argentina, Australia, Canada, China, Germany, the United States, California, Florida, Oregon, and other countries to create human cryopreservation facilities. Cryo-Rus charges €12,000 for neurocriopreservation and €36,000 for whole-body cryopreservation, with standby, stabilization, and transportation costs varying depending on the origin of the cryopreserved patient. The Shandong Yinfeng Life Science Research Institute in China was established in 2015 and is currently preserving 12 patients. Additionally, there are also the Southern Cryonics in Australia and the European Biostasis Foundation Cryonics Center in Switzerland that have emerged in this field. The first cryopreserved human in South Korea was an 80-year-old woman who resided in Gyeonggi Province and passed away from cancer. The applicant for the service was her 50-year-old son. The cryopreservation procedure took place in 2020 through Cryo-Asia, which was established in South Korea by Russia's Cryo-Rus. The cost of the procedure exceeded 100 million won. After freezing the deceased's body, it was transported to the airport using a limousine and then sent to Russia for further cryopreservation. James Lovelock, a British scientist, is indeed known for being one of the first scientists to successfully freeze and revive animals. In 1955, He froze mice at 0 degrees Celsius and then used extremely short pulse microwave radiation to bring them back to life. The Defense Advanced Research Projects Agency, DARPA, in the United States has started funding research on induced or suspended animation, which is a step towards human cryopreservation. This research aims to temporarily stop the heart and brain to provide treatment to specific patients in the future. Furthermore, there are also efforts to freeze and preserve eggs, sperm, and embryos so that they can potentially be revived and used for reproduction at a later time. In November of last year, Rachel and Philip Ridgway, a couple from Portland, Oregon, received a remarkable donation of frozen embryos that were preserved for a staggering 30 years. They gave birth to twins through the use of these donated embryos. Prior to this, there was a record of a baby being born from a 27-year-old frozen embryo, making this another significant milestone. The frozen embryos for the twins were created on April 22, 1992, and had been preserved in liquid nitrogen at a temperature of -200 degrees Celsius for 3 decades before being implanted. There is a joke that these babies could be considered 30 years old if we were to count from the time of their embryo formation. One of the treatment methods that gives a positive signal to cryopreservation is hypothermia therapy. Lowering the body temperature can cause the heart to stop, but it also reduces the oxygen demand of brain cells. If vital organs are sufficiently cooled before cardiac arrest occurs, the inevitable cell death due to inadequate blood circulation is delayed, giving emergency services more time to save the patient's life. Another positive signal comes from the fact that some organisms already experience survival in various types of sub-zero hibernation. For example, Uricitellus parrii undergo hibernation for up to 8 months each year. During this period, their body temperature drops from 36 degrees Celsius to as low as -3 degrees Celsius, and the external temperature can reach as low as -30 degrees Celsius. Indeed, the body of the ground squirrel prevents the blood from freezing by removing all particles that can form ice crystals. This allows the blood to maintain a liquid state even at sub-zero temperatures, a phenomenon known as supercooling. Yes, various fish species in polar regions survive by using a substance called antifreeze protein. The tardigrade, also known as the water bear, is a prime example. Water bears, which grow to less than 2 mm in size, have been in existence since the Cambrian period, around 500 million years ago, and have shown the ability to withstand temperatures lower than liquid nitrogen, at -196 degrees Celsius. Indeed, as previously mentioned, Caenorhabditis elegans have shown the ability to preserve memories when frozen in liquid nitrogen and later revived. Although the precise molecular and electrochemical characteristics that underlie consciousness in the brain are not fully understood, this experiment supports the possibility that the brain's features responsible for encoding memories and determining behavior could potentially be preserved even during and after cryopreservation. That's correct. In cryopreservation, a method called vitrification is used instead of freezing. Freezing water can form sharp ice crystals, which can damage cell membranes and cause cell death when thawed. To prevent the formation of ice crystals, cryoprotectants are used to remove water from within the cells, resulting in a glass-like state similar to melted glass. This process is called vitrification, where the cells are preserved in a non-crystalline, glassy state to avoid the harmful effects of ice crystal formation. Scientists are indeed conducting experiments to preserve the structure of synapses, the junctions between nerve cells, at the moment of death. As discussed in the previous UnicornDNA video about neuroscience, research is underway worldwide to create a connectome, which is a map of the brain consisting of around 100 billion nerve cells. Futurist Ray Kurzweil predicts that by 2045, a point known as the singularity, where artificial intelligence surpasses human intelligence, could be reached. In the not-too-distant future, it is speculated that our knowledge, memories, experiences, and emotions could potentially be uploaded to the cloud, offering another way to overcome death. That's all for today's video. Thank you so much for watching up to this point. I appreciate your support.